All right, so we're going to go through 1 to 16 on the review today, and I'll kind of explain them, give you the key here, and see how it all goes for you. So this one's actually kind of a tough one because you have these two pieces to this function. This is a piecewise function. It's got two different things going on. The range is actually weird. So if you look at the range, what y values this covers, so this graph spans everything between 0 and 2, which is what I have right here. So from 0 to 2, 0 is included, 2 is included, so is everything in between. And then it has nothing in between here, and then it just has this horizontal line at 3. So 3 is included as just like a single number. So basically it's everything from 0 to 2 and in between, and 3. Pretty weird range. So it's not just from 0 to 3 because, for example, 2.5 is not part of the range. It's kind of a weird one there. The domain, so left to right, -4 is as far left as it goes. It exists all the time, then it jumps up to here, and exists until 4. So this one is -4 to 4. No holes in the graph at all there. Increasing, the only time it increases is right here, because then it decreases and then it's constant. So increasing would just be from -4 to -2. Only one x-intercept, because this is the only one that actually touches at 0. This is open, so it's not there. So just that should be a -4, is the x-intercept. And then rate of change, and remember, these are x values. So we're saying from when x is 0 to when x is 2. So when x is 0, you're right here. When x is 2, you're right here. The rate of change between those points is, well, there's no rise, so it's rise of 0 and run of 2. So it's like 0 over 2, which is just an average rate of change of 0. All right, 6, kind of more of the same here. They give us a graph that we need to make. I just drew it based on knowing what this is going to look like, but you can also just graph it in a calculator, decimals, whatever. But this is going to be shifted right 2 and down 2. So I went right 2 and down 2, and I put my vertex, and then I drew my absolute value with slopes of 1 and -1. When is it increasing? Right here. So that'd be from 2 on to infinity. When is it decreasing? That's this portion, negative slope. So -infinity to 2. Always looking at x values with these intervals. Let's see. Then we got, when is it positive? It's positive twice, here and here. So this would be from -infinity to 0 for the first one, and from 4 on to infinity for the second interval. Then the negative interval is going to be this part, which is just from 0 to 4. Domain, everything. This graph goes left and right forever. So negative to positive infinity. The range, lowest value it ever reaches is -2. Highest value would be infinity. Then it gives a couple rate of change questions, which actually aren't too difficult because they're either going to be, if they're part of this, they're going to be -1. If they're part of this, they're going to be 1, because this either has a slope of 1 or -1. So when they say from 0 to 2, so from this point to this point, that's just got a slope of -1. It's going down 1, right 1, down 1, right 1. Boom. And actually, it's the same thing over here. When they say from -4 to -1, wherever we're at up here, it's still going down 1, right 1, down 1, right 1, all the way there. So we're just counting rate of change in that case. Number 7, this one I remember confusing people when we had one like this on the quiz. So it says, fill in this table, and they're telling you that g of x is just taking 4 times f of x. So when you input the same number, when f of x gave you 8, g of x is going to give you 4 times that amount. So it's going to just be 32. And 4 times that amount, 24. 4 times that amount, 4 times that amount, so on and so forth. Once you see what it's doing, it is easy. It's not a hard one to do. You just got to understand, what is that notation telling us? Here's writing your transformations. So you got, in this case, left 1 and up 2. You can see the vertex there. This one's just right 2. This one is right 1, up 3. Also, don't forget the negative to flip it over to reflect it. So hopefully feeling pretty confident on that. Here's kind of more of the same with an x squared function. So to just shift up 2, you're just going to add 2 at the end. To go down 2 is the -2 at the end. Left 3 is the +3 in the parentheses. Reflected is negative. Right 4 is going to be a -4 in the parentheses. All of these can be graphed and checked. If you graph this, visually look at it and say, hey, is it the same as x squared, but it's just shifted up 2? Either it is or it isn't. You can tell by looking at the graph of the equation. Other page here. So what is that? Number 10. All right, piecewise. Okay, so this one gives you the graph, and as you come up with which function matches it. This is going to have, there's 3 different parts here. You got this x squared part, you got this constant part, you got this linear part. So this one is just plain old x squared. You can see the vertex is at 0, 0. It's going up 1 and over 1, in these directions. So it's just plain old x squared. And then you just put a comma, and then you say, what domain does it exist? And so this exists from negative infinity, and it stops at 1. And it does include 1, so we have it equal to. This is just a constant line, which is going to just be x equals 3. Or sorry, scratch that, y equals 3. So it's just 3, and you say this exists from 1 to 2. Not including 1, but yes, including 2 because the solid dot. And then this one is a linear function, like an mx plus b. Its slope is 1, right, because it's going up 1, right 1. And if you follow it back, its y-intercept is going to be 0. So it's just 1x plus 0, or just x. And it exists from 2 on to infinity. And so there we go. So just kind of walk through it piece by piece, left to right, coming up with the functions and their domains that they exist on. More of the same on the one below it. This one you have 2 constants and a linear. So this constant is at 4 and this constant's at 3. And this linear function has a slope of negative 1. But it also crosses at 0, so it's like plus 0 for the y-intercept. And then for each one, just look at the domains. The first one is from negative infinity to negative 2, including the negative 2. This one, negative 2 to 2, including neither of them because they're both open. And 2 on to infinity, including the 2. So again, just writing the piecewise function from the graph. So you should be able to do any of the functions we've done here. You should be able to do these. You should be able to do absolute values. You should be able to do, if we had x cubes and stuff like that, it could be on there. But really, this is what we did here with basically these 3 types of functions: constant, linear, and quadratic. Okay, number 12. A little more with piecewise, or actually this is technically called a step function. So this is where basically every 250 people, what's the y here? The number of performances has to go up. So as they can only hold 250 people in their auditorium. So as as it goes up, they have to have more performances, 2, 3, 4, so on. So this is a graph of if you have 0 to 250 people, you do 1 performance. If you have between 251 and 500, you're going to do 2 performances, so on and so forth. So the graph should look like this. It's open on this end because it doesn't include the first number. Then they're always closed on the right end because they always include the right number. Also, as for domain and range, domain, we just look at it. Domain's literally this is right here. We just need to write it. So it's pretty much everything from 0 to 1500, not including 0, but yes, including 1500. The range, on the other hand, is literally just these specific numbers. So it's not everything between 1 and 6. It's 1 or 2 or 3 or 4 or 5 or 6. So I just listed it as a set of numbers because, again, you can't have 1.5 performances, so it's just a set of whole numbers. Some more interval stuff coming up here. So when is this graph positive or negative? So I graphed it. I did all these by just hand, but you can graph them in a calculator or anything too. But I noticed it's just x squared, but it's shifted down 9. So I just drew it. It's going to cross at negative 3 and 3 because that's the values that would make this equal 0. And so it's positive here and here. That's when it's above the x-axis. So I said from negative infinity to negative 3 and from 3 on to infinity. The negative interval from here to here, negative 3 to 3. More of the same. This one flips downward because it's a negative x squared. It's also shifted up 25 units, but it crosses at negative 5 and 5. You can either think of that, you can come up with it from the graph, the table, however you want to come up with it, but definitely got to come up with it. So this graph is positive here, so from negative 5 to 5. And then this one has 2 negative intervals because negative here and here. So negative infinity to negative 5 was the first one, and 5 on to infinity was the other one. Okay, for the graphing ones, I left them to just do here because we need the graphing calculator anyway. So I went ahead and I typed this first one in. And I'm doing the graphing calculator. If you're using Desmos, you just type them in there. It's the same process. But you're looking for the solutions. The concept you got to know here is the solutions are the intersection points, specifically just the x values. Because this problem only cares about x's. There's actually no y's here. So on the calculator, we go second calc, and we pick intersect. On Desmos, you just click on there, and it's right there. So if I want to find this intersection, which is where my cursor pretty much is already, I just got to move it there and press enter 3 times. And then it'll give me my value. So it says nearest tenth, so this would just be 0.2. And then the other solution, you can't see that. The other solution is going to be the one over here. Same process, just move your cursor on over. And we press enter 3 times. 1, 2, 3. And it'll say about 4.8. And so that's it. Those are going to be our 2 solutions. The next one, same process, different equations. So we've got a quadratic, and we've got a linear. And we can take a look at the graph. It looks like so. So two solutions once again. Let's go ahead and get them. Intersect. Get this left one first. 1, 2, 3. Negative 2.4. And repeat over here. 1, 2, 3. 0.4 approximately. So again, just nearest tenth on those because that's what the instruction said. And we're looking pretty good. All right, last one for today. We're going to say solve this system. That's a pretty broad question. You can do this a ton of ways. Personally, I would probably do it with a matrix just because it's already in standard form. Anytime they're in standard form, I like using a matrix. We'll see that tomorrow, though. So like on the problem 17, I think starts talking about matrices. So let's actually go a different route. Let's go ahead and do like elimination just to show you another option here. So if I wanted to do elimination, I'd want to multiply. I need to get these x's and y's to cancel somehow. So I'm going to multiply this one by negative 4. So this whole bottom equation I'm going to take by negative 4. So that's going to then be negative 12x plus 4y equals negative 16. And now I can add these two equations together, the top and the bottom one here, because now the y's will eliminate. All right. So if we eliminate those, that's going to leave us with negative 10x and negative 20. Divide by the negative 10 and get 2. So x is 2. We do need the corresponding y value. So let's go ahead and take this equation and plug it in. So if you plug 2 in for x and solve for y. So you have 4 minus 4y equals negative 4. Subtract that over. Gets negative 8. And divide by negative 4 to get 2. So 2, 2 would be our solution. So usually we write it as a coordinate. Look a little something like that. You can also always check these. Like so, multiple choice test, you're going to see 4 options there. You could just take this and see, does 2, 2 work in both of these? So I already know it works in this one because we just did it. But if you plug it in here, 3 times 2 is 6, minus 2 is 4. Boom. Just a tip for multiple choice tests. But anyway, there's elimination. We'll look at matrix tomorrow since that's on more of the tomorrow problems.